Hello everyone, we are going to learn about ionic compounds formula and the naming. We're going to spend about 2 days to finish this up. So whenever you see this part, like in the orange color frames, I would ask you to write this down. Okay, and when we write a formula, means in chemistry how we are going to use the element symbols to write the ionic compound. When we write any formula, we always write the metal first and then the non-metal after. And one more thing is for any ionic compounds, it has a net charge of 0, means the whole compound has no charge. What does it mean is the total positive ion charge would equal to the total negative ion charge. So please write this part down in your notebook, and I'm going to explain more detail about this. So basically, if you still remember, the ionic compounds is formed by electron transfer. The metals give away electrons and the non-metal receive those electrons. So whatever numbers, for example, the metal for sodium, it gave away 1 electron, chlorine receive 1. And magnesium need to give away 2 electrons. If one magnesium bound up with chlorine, one chlorine can only receive 1, so it needs to bond up with more chlorine atoms. That's what does it mean by total positive need to equal to total negative, because whatever number of electrons the metal gave away, the non-metal need to receive the same number of electrons, because the electrons can't go to anywhere else. Okay, it's still in the system. So please write this down. And I'm going to give you a few examples. For example, when sodium, which is a typical metal, react with chlorine, when they meet together, they're going to form a ionic compound. And sodium gave away 1 electron, chlorine received 1. Sodium become to a positive 1 charge, chlorine become to a negative 1 charge. So when we write a chemical formula for sodium chloride, which is the table salt we have every day, we're going to write the metal first, which is Na for sodium. And we're going to write the non-metal after that, which is Cl for chlorine. And this one is positive 1 charge, this one negative 1 charge, so they cancel out. The net charge for the whole system is 0. Okay, when potassium is reacting with fluorine, and again, we put metal first and non-metal after that, and the total positive charge need to equal to the total negative charge. For this one, it's positive 1, means potassium need to give away 1 electron, fluorine receive 1, so they balance up. And when we write the formula for potassium fluoride, it just looks like this. It's a K represent potassium, F represent fluorine. So these two are pretty simple because each one of the metal need to give away 1 electron, and each one of the non-metal need to just receive 1. But however, there are more complicated ones like this. For example, magnesium, which is in group 2 of the periodic table, it forms a positive 2 ion, means magnesium has 2 valence electrons. They need to give away 2 electrons. And the 1 chlorine can only receive 1. It only needs 1 because it already have 7. So when the 1 magnesium meet with a chlorine, how are they going to form a chemical compound? And the same for sodium. When they react with oxygen, 1 sodium only need to give away 1 electron, 1 oxygen needs 2 to be stable, to have a full valence electron arrangement. And the aluminum has 3 valence electrons. Aluminum needs to give away all 3, and the 1 oxygen only needs 2. So when aluminum react with oxygen, how are they going to form a compound? Okay, it involves some math, some kind of calculations, because we need to figure out that total positive need to equal to the total negative charge in the whole compound. So people came up a easier way to do this. Instead of doing math calculations, we're just going to use a method called the crisscross method. What does it mean by a crisscross? Okay, I'm going to explain the detail. For example, we have magnesium react with chlorine to form a compound called magnesium chloride. When they form a compound, how are we going to write this formula for this compound? So what we do is first, we write a symbol for the metal, which is magnesium, which is Mg, with the charge as a superscript. Magnesium always form a positive 2 charge. It's in the group 2 of the periodic table. Okay, and then the next thing you want to do is write the symbol for the nonmetal with the charge as a superscript. One more time, it's write the symbol for the nonmetal, which is Cl, to represent chlorine, and the charge is a -1 charge right on the top right corner as a superscript. And then what you're going to do is write these two symbols right next to each other, right? Magnesium, Mg first, metal first, and Cl, non-metal, after. What you're going to do is you're going to swap and drop the numbers. Like this one is a 2. What you're going to do is put this 2 right next to chloride, and it's at the bottom foot, at the right side the foot, okay? And then this number 1, put it right next to magnesium. So basically chlorine is -1 charge, you put the 1 over here, and this is +2 charge, you put the 2 over here. We call it crisscross or swap and drop. And don't swap or drop the charges, only the numbers. Okay, so magnesium chloride look like this. Okay, whenever there is a 1, we don't bother to write the 1. Okay, basically it's MgCl2, that's magnesium chloride. Please write all this part, this one and this one, in your notebook. Okay, here, where do you find those charges? Again, they are in the periodic table, and I would not ask you to remember. Please, it's better to label it if you have drew a periodic table or if you have saved the periodic table in your computer, or you have one print out one, or somehow you have one in your house. I hope. I always gave away periodic tables, but this year we can't give you anything. I have also posted the slides in the pre-work folder. You can go to the slides, copy this page into your notes if you have electronic notes, or copy this page, copy and save this page into your chemistry folder in your drive. Okay, so there is a pattern, +1 charge for the whole group 1, +2 charge for the whole group 2. For example, if people ask you, what's the charge for calcium? You can just go to the periodic table, find calcium, which is Ca, and figure out the charge is +2. And people ask you, what's the charge for oxygen? What you do is go to the periodic table and find the oxygen, and you figure out it's in this last third group. It always forms a -2 charge. Okay, that's how you find the charge. Okay, so there's a couple more detailed things about how to write this formula. So again, when this subscript, we call those subscript, which is in the foot. Okay, those are called superscript. Okay, whenever there's a 1, you don't need to write it. So magnesium chloride, you just don't bother to write the 1. This represent there's 1 magnesium. Okay, so this one is magnesium chloride. It's MgCl2. Mg is magnesium, Cl is chloride, and this 2 means in each magnesium chloride compound, there's 2 chloride ion or chloride atom combined with 1 magnesium atom. Okay, so this represents how many of each atom you have in the compound. Okay, so to understand it better, you may look at this picture in here, we use the Lewis dots to represent. Magnesium have two valence electrons, so there are two dots. And the one magnesium need to give away those two electrons. One chlorine only needs one. So one magnesium will give one to this chlorine and give another one to this chlorine. So one magnesium will bind with two chloride and form a magnesium positive 2 charge and chlorine's negative 1 charge, but there it needs two chlorine to bond with one magnesium. That's chemically what does it mean? Okay, it's like one give away two, and each one receive one, so it needs two of those. Okay. So the next thing is if the subscripts are the same, for example, magnesium has a positive 2 charge, means it gave away 2 electrons. Oxygen is a negative 2 charge, means one oxygen need to receive 2. And in that case, if we swap those two numbers, we put these two over here, these two over here, it becomes to magnesium oxide. We don't really bother to write those two, okay? Because two magnesium bound up with two oxygen means one magnesium will bound up with one oxygen. So you don't need to write it. They cancel out. Magnesium oxy and oxide oxygen. It look like this: Mg and O. Okay. So the last thing I need you to know is how are we going to call it? For example, sodium is Na. This Cl is chlorine in the periodic table, but somehow we call it sodium chloride for table salt, right? So the rule for ionic compounds naming for a binary compound, a binary means contains two, bi means two, different kinds of atoms, one metal and one non-metal. Okay, binary compounds. Tomorrow we're going to learn some more complicated compounds. Binary means one metal and one non-metal. Okay, whenever one metal and one non-metal form an ionic compound, when we name it, we keep the name of the metal. The metal's name does not change. It's exactly the same as the name in the periodic table. For example, sodium is still called sodium. Magnesium is still called magnesium. We always put the metal first. And for the non-metal, it will change the last part of the word to an ID. We keep the first few words, the few letters, and then put an ID. For example, chlorine become to chloride, so INE become to IDE. Oxygen become to oxide, we keep the OX. And you may hear people say nitrogen, it become to nitride, and the fluorine become to fluoride. We're going to practice more during the live class. Okay, that's all you need to know for today. Thank you for watching, and we're going to learn more during the live class.